Okay, now we're going to look at some examples of composite functions and work with them. So the question given here is if f of x is equal to 3x minus 5 and g of x is equal to x squared minus x, find f of g of 3. So to do that, we need to recognize that g of 3 is serving as the input of f. So the first thing that's going to happen when we plug 3 in is we need to evaluate what g of 3 is. So g of 3 is going to be equal to 3 squared minus 3 is equal to 9 minus 3 is equal to 6. So g of 3 is equal to 6. That means f of g of 3 is equal to f of 6. So 6 now gets input into the f function. And the f function was 3x minus 5. So f of 6 is going to be 3 times 6 minus 5 is going to be 18 minus 5, which is equal to 13. Oh, and I forgot a bracket over here. So f of g of 3 is equal to 13. Continuing on with the same stem of a question, now we want to find g of f of 3. So in this case, f comes first. So f of 3 is equal to 3 times 3 minus 5, which is equal to 9 minus 5, which is equal to 4. Now, g of f of 3 is equal to, f of 3 is equal to 4, so g of f of 3 is equal to g of 4. G of 4 is going to be equal to 4 squared minus 4, because g is equal to x squared minus x. So that's equal to 16 minus 4 is equal to 12. So g of f of 3 is equal to 12. Notice that g of f of 3 and f of g of 3 were not the same. Okay, now, we're given the same two functions, and we're asked to express f of g of x as a single function of x. So we're trying to stay general now. We're not plugging in any values for x. We're going to keep x there as a placeholder, but we want to express f of g of x as a single function of x. So what that means is this. F of g of x is equal to f of x squared minus x, because g of x is equal to x squared minus x. Now, f is equal to 3x minus 5, so everywhere we saw an x here, we have to plug in an x squared minus x. So f of x squared minus x becomes 3 x squared minus x minus 5. So let's go back and look at what we've done so far. F of g of x means f of x squared minus x, because g of x and x squared minus x are equal. So we've taken, instead of g of x, we've substituted x squared minus x. Now, f of x squared minus x means take the f of x function, and everywhere you see an x, replace whatever's in the brackets here. And that, in this case, x squared minus x is in the brackets here. It can be a little confusing at first that you're replacing x with something else that has x's in it. But that's what happens when we express composite functions in this general form. So now, everywhere you saw an x here, you have to replace with this, x squared minus x. So 3 times x squared minus x minus 5, and that becomes 3x squared minus 3x minus 5 as we distribute. Okay, so that's how to work with composite